Good morning, ladies and other humans. Um, is Mr. Shan here? Hello. Hello, hello, hello. Oh, hold on. All the six over there. Ronaldo. Hmm. Is what? Is what? One mid-semester holiday or something? It's a holiday? What's surname? All right. Anybody try calling? Late, you know? Oh, God. Oh, boy. So what time class are going then? Oh, I'm soon come. All right, cool, cool, cool. All right, no problem. No problem, no problem.
Good afternoon, guys. I'm sorry, good morning. It really feels like afternoon. Good morning.
Morning, sir.
I sincerely apologize. I had no food in the house and I had to go to the market. And trust me, it was market ram. But forgive me, let us see if we can go. Yes. Oh Lord, what am I looking at now? I am not even so settled. Um, Applications. All right, so I would have sent you the document on Saturday last week, and I'm not sure how many of you would have gotten the chance to go through the document.
Hi, sir. Morning. I'm still not added to the group.
Are you not added to the group? Peter Gay? Peter Gay is here? Oh no. Peter Gay is not here. All right. I will see to it that you get added to today, Shan Shan. Oh Lord. Orlando, all right. All right. Everton, can I call Peter Gay for me, please? Oh dear. All right. So we did Newton-Raphson. We did some differentiation. We did Maclaren's, and that's where we are. I would want to look at another Maclaren's before we are going to the exponential. Oh, I did the exponential function. I did the exponential functions with you? No, I didn't. Yeah, man, I did. Yeah, man, I did the exponential functions. Yeah, man, I did the exponential functions. I did the exponential functions with you. I wanted the logarithms. All right, so I had the logarithm functions to do. And then I did Maclaren's. All right, so I did Maclaren's. I have time run out on me in doing the Maclaren's last week. All right. All right. What I want to do is to give you as a little warm up. I want to give you a little warm up. Let's see what the warm up is going to be. All right. Let me just do this as a warm up. It's not a test. It's just copy. It's just a little warm up exercise. I want you to attempt for me, and then I'll go through solutions with you. So if you don't know what to do, it's not a problem. For now, I just want to give an attempt. Find the derivative of the function. All right, so you don't do the logarithm function to just yet. So you can't do that one just yet. But you can do that one. You can't do this one yet because you can't do that one, but you can do this one because you've done that. All right, so I am projecting a few questions that I want you to attempt for me. I'm going to give you about 20 minutes, at which point in time I can go draw some tea since I don't eat from morning. I just came back and decided to log on. So I'm going to give you some questions to do for me. It's about, I give you about 20 minutes to attempt as many of these questions as I possibly can. And I'm particularly interested in the differentiation since we have done the differentiation some weeks ago. If you're struggling with the Maclarens, that's okay, because at least we only started Maclarens last week. So start with please. I'm giving you about 20 minutes in total, and then I'll be doing the solutions with you. So start with please. If anybody else joins, let them know exactly what we're about. All right? I'll be back in a few, please. Thanks.
Sir? Can someone send the questions in the chat, please?
Which questions?
The questions will Sir give away.
When?
You not just say me give us some.
Seem like him forget for sharing screen.
Yeah,
Thank
I mean, I
God.
call him before him gone and Sir run gone.
Yeah, sir, I gotta make stew peas tonight. Sir, I get him ingredients to him stew peas.
The group him send it, and show me not part of the group I could even say.
I don't go make no stupid. Just you stay so Bridget? Look how long me your parry. Are you out here? Boy, me I tell you. I saw you. I'm Peter Gay, and you're part of the conversation.
Sir, I'm just joining back again. I'm internet unstable.
Boy, I mean, no, can't keep up with you. Anyhow, all right, Peter Gay, please do me, I beg you. Add Shan for me, please. Do.
I got last week.
Oh no, other. We don't want Shan
All right,
start.
send a number coming in the group, Sonny. Sir, the editors start work them hard, you know, sir.
Guess what? All right.
It's my teacher.
Sir, me I struggle. The first me do, sir, me get 58. I'm do one next one and me get 80. And sir, me open one actually me there work, me accidentally close it. Come I think it was the regular assignment and a 0. But try a next one, sir. And I told you, me I struggle. Me take all 1 week to finish one.
Come upon WhatsApp right now. Let me tell you a secret.
No. Talk. One ear. How we are this, sir?
It's a record. It's a secret. It's a record. Come in now, Peter Gay.
Right now, sir. All right.
What is? What?
Sir, like a well class. Now call it when you take a look at break and I'm make a
Mr. Call me no before me forget. No.
Right, no.
Mm-hmm. Yes, sir. My
Sir,
friend,
let's
two peas and
add me to edit stuff as well, please.
My friend, I make true peas and I have private call, secret call, you know.
That's your phone.
No, the baby, that's not my phone. No.
Can you have her check out her calculus book, please? It's time for class.
Sure, could you add him to edit stuff and get the chances, please, sir?
Okay, Peter Gay, you can come back now. All right, so
This is too cool. Yo, last semester to write it. I like it.
Yeah,
spicy.
Nice.
Mm-hmm. No, you can't go outside now. You have to finish eating first. Yes, plane fly outside, baby. Huh?
Have baby take out calculus 1 for me, please. I don't know if she passed calculus 1 yet. Take out calculus 1 book for me, please.
Me to tell you that she's telling me every letter that she's seeing on the screen right now, and because she see plane with Orlando, she's saying that the plane fly outside, and the S is for snake and whatever. Come here, open.
Okay, I send in our message. Tell her that Uncle send our message.
Okay, no more monkey. Open.
No, don't look at that, you know.
Sir, morning, sir.
Morning.
You see all them foolish about don't look at daddy now. I hear her name just come up on the screen, but M she say M for monkey. I hear come talk about don't look at daddy now. You know, easy, you know.
Come, tell her to read for me. Come on, tell her to read for me.
No, listen, she just turned 2, you know, she not start read it, you know, she just okay,
so just formulating our letters and things.
Yeah, come here, open baby.
Wash your hands so water.
Yes, wash your hands with soap and water, baby. Okay.
Yeah. All right, so who this say hello? I can't the bad bargain there.
Sir, I mean, I thought, sir, Kimani.
Yeah, what Kimani?
Okay. Come, daddy going in class now. You finish eating now?
I don't understand. Okay, all right. Hold on. All right, no, hold on. All right, hold on.
Send to me as well, sir.
I know, but did I not? I'm just trying to remember. Did I not send a message in the group to ask if those who needed to be added and Alton responded? Anyway, all right, never mind. I'm almost sure that I did ask, but never mind. I'll get you guys done up today. Do me a favor, guys. You have some questions. Am I still sharing? No? All right. I want you to start working on these questions for me, guys. Please, it's important. I'm right here. I want to boil it, but we're right here. I want you to start working on these questions. They can give you these questions. I'm going to tell you straight up. Number 2 is a tip difficult. Number 2 is a tip difficult, even though all these questions are past paper questions, incidentally. Right? Question 1, question 3, and question 4 are fine. Question 2 is slightly difficult. So if you can't go through that, it's fine. You have about 10 minutes out of the 20 minutes left. Anybody finish question 1?
Sir, you wasn't sharing in us, sir.
Oh, Jesus. I thought I was.
No, sir, that we that talk about.
Oh, Jesus. Lord Jesus. It's a senior moment, you know. I threw my girl get her Olympic record, you know. Jesus. All right. See it there now. You seen it now?
Yes, sir.
All right, cool.
Is what I go on here. Stroopies, private calls, and then I love you. Why? All right, what did I miss? I had to step away.
Just attempt these questions on screen for me, please.
Can I move that ugly something there, sir?
Yeah, let me just stop share and then go back again.
Okay. All right. Let me just get this stuff out of the way. So, sir, big you want scholarship, no?
Soon.
Remember, you tell me, no, sir. So when time I tell you, say, offer, tell them, say, offer the tuition, I go pay by it, some action, and no, it's just, let's pull, deduct it out of your salary, you know? Right, so for two. Record. What up, bro? What looking at for? Differentiate, differentiate, differentiate. Shit. Where's my writing? All right, I don't know if I'm me alone mad, but sir. Sir. See,
Yes, Papa.
sir. All right. When I have, all right, so it's the first time that is differentiation of the second, correct? We get that. But the 2x raised to the power of 2 up here, so kind of mix me up, sir. But do it 2 times already, and I kind of me multiply it out first and say it raised to the power of 4, 2x raised to the power of 2. No, x raised to the power of 4 times, and do that and then differentiate that and then carry it out. That's the way we should take it, work with it. Second bracket. No, yes, no.
All right, so it's the first times the differentiation of the second
time
plus the second
plus
times
the differentiation of the first.
Very good.
Correct. I got
Excellent.
that down.
Uh-huh.
But the bracket, I'm saying the squared, the cube, all squared, right? The all squared. Do I work the bracket first and then do all of that, or do I leave it as it is?
Is that happening?
What this, sir? Sir, I know you watch Olympics and something now. Easy. Talk to me now, sir. Sir, gone now. Kind of like that something, you know, something I make me think too. Sir? Gone? Hello?
Sorry, Everton, that system went.
When by that system went?
Go again, Papa. That system went.
Why, your brain done?
No. The computer was gone.
Oh, okay.
Yeah, so right. So you got the point. Right, hold on.
Ooh, come back.
Sir, we are here 3 times.
No, but hold
Sir,
on.
just mute the mic on one of the devices.
No, hold on.
Yeah, it sound better now.
All right, so are you hearing me?
Yeah, man, loud.
Are you hearing me? No,
Yes,
not
sir.
yet.
Yes.
All right, so I just hold on. I just disabled the one from the computer,
Yeah.
but clearly something is still active in the background. So that's regular echo. So just bear on until the computer comes back up, please.
All right.
All right, so you've got the part where it says the first times the second plus the second times the first. Excellent. Talk again.
No, all right, cool. So what I'm saying is that the second bracket, which is the second, correct? It's all squared. So do I work the all squared first by and remove the brackets, then differentiate it and work? Or do I leave it as is? But in order for me,
Remember, there's a power rule right here saying, no, Papa. The second is a power rule.
Yes, sir, but what he's saying is that the x squared plus x and all squared. So that's what he's saying, that he should work out that first, the square first.
The all squared. Should I remove the brackets?
No, only remove the brackets.
Meaning that I would just with the all squared, I would then okay for you just put x raised to the power of 4 plus 2, right? And then I differentiate it. Wrong, right? Or does
hold on. Don't get frustrated. Don't get frustrated. I'm supposed to get frustrated because the system here is, you remember from them long time that Everton.
Well, me tell you if I make my work. It's all right, sir. You're good.
Yeah, man. It's trust me. But anyhow, me and you forgot to talk because it is. I don't know what is happening. But anyhow, so I just fully switch over now to the tablet. So bear on with me, as I try to work the question.
I mean, I want you to work the question.
No, no, no.
Why you
I
sit
know,
down there?
but I
I'm why you
no,
watch
no.
more
I
you.
know, but guess what? I want to see that. I want to see. I want to see that you are. Oh, I need to stop share here. That you are where exactly you're having a difficulty.
Okay.
So I
All
have
right.
no. I don't have no problem doing this stuff, and I can generate many more of these questions. So it's not an issue. It's just for me to assist you as you go. All right. So
No, know where you're going,
so the
sir.
question
You
said,
sound like you have COVID, sir, and your nose around, sir.
No, 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 no. It's just that the time is so hot.
Oh yeah.
So me I sleep with the fan now, so it kind of make my throat kind of just feel a little
Mm-hmm.
groggy.
So it's starting, sir.
Yeah, me know. But the blood is against it because me soon go for my turmeric, I'm a ginger, I'm a
Mm-hmm.
garlic.
Can't help you. Trust me.
Mm-hmm.
Trust
And
me.
I you
Can't help
tell.
you. And you have to be careful of your harsh you make the garlic kind of make your throat sort of. But anyway, continue.
Yeah, all right, cool. Hold on there, hold on there, hold on.
And then the group like terms. If a group like terms, that's so. Come again. All right. So let me see this now. Where do you along the way? The first this. Second time differentiation of the first. Differentiation of the first of the x plus. Okay. So you plus that now. X squared. The x squared at bottom right is some squared. All right, what the next question? This page. What the hell is quotient? Sir. Sir.
Give me half a second, please. Coming to you.
No, just somebody just start the quotient rule for me now. Please. I don't know what the hell me right now. Oh, this quotient rule. Quotient rule. The denominator times the differentiation of the numerator minus the. Why the hell? Why am I never gonna write it? The denominator. denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over squared. All right. Okay. So then, let us say, oh, and then we just group like terms and let's work the top with the bottom. All right, cool. So, the denominator times the differentiation of
All right, sorry about that. Let's go. So yes, so this is a product rule. I'm very happy that you recognize that it is a product rule. So let us go. It says the first. It says d by dx. Oh, let me show you what is it. So I'm calling this a first, and I'm calling that the second. All right.
all right.
So it's going to be the first. The first is going to be dy by dx. The first is x plus 1. X plus 1
Yeah.
times the differentiation of the second. So when I'm saying the second now, the second is a power rule, right? So it's all squared, so it's a power rule. So I'm going to say 2 times x squared plus 1 to the first, and then I have to differentiate what is on the inside. That's what I was saying to you. So that's why I wanted to proceed. 2x. And then plus the second. I'm going to stop right here and then give you a chance to just finish off. Plus the second times the differentiation of the first. And when I differentiate the first, I get 1. All right, take it from there now. So remember, it's the first times the differentiation of the second, but you have to look. It's a power rule.
I did
Remember,
get it, but I didn't put the times at 2x.
no man, you have to.
All right,
can I
sir.
get you guys to remember?
Sir.
Yeah, Papa.
Sir, the 2x, sir. That 2x that kind of have me away, sir. Explain how we get the 2x, sir. That you differentiate the power. So you're gonna end up with the 2x, the 2 bracket that you leave the 2 there because that is there. Then you're gonna differentiate again what is in the. How the hell did get that? Where the 2x come from?
That's what I'm saying. I'm differentiating what is inside the parentheses.
Oh, you differentiate what is in the parentheses a second time?
No, the first time. That's all I've never differentiated it before.
Okay,
I'm different. All right. Hold on.
The first,
1, 2,
right,
3.
times the differentiation of that means that turns to 1. Fine. Okay, so you differentiate what is outside of the brackets first. And then you differentiate what is on the inside of the bracket. Am I correct?
You are correct.
And then you times that, and then you times it. But got you.
Let me say something. And I want you all to listen to me. This is a product rule. But included in the product rule is a power rule. In the quotient rule, I could have the power rule also. In the chain rule, I could also have the power rule. What the power rule says, differentiate everything as a whole, then differentiate what is inside the parentheses.
Sorry, no, first I tell me that, sir.
No, man.
Sir, before I go any further, right? But me do wrong, me just, no, I'm gonna get 2x squared right this stuff. But sir, I get the 2 right there. So you have the x plus 1 times 2 bracket x. Oh, x2 plus 1 bracket. I want that, sir, Bessa?
Mm-hmm. 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 This one you're talking about, right? So
Sir, I see where your mouse, where your cursor there, but sure, me see it now.
let me show you what I just did. I just put that one right there to show you that it's a one.
Oh.
Hold on. So I teach in the business class with students this very thing, and I remember typing something in their document.
Sir, so I get the 2x right there, so sir.
Yeah, man, that's
I lick this for 6, you know.
I know, Shanice.
Just
give me
tell
half
sir,
a second.
Let us tell sir that.
Because the truth of the matter is,
That's one.
I'm trying to find it because
All right, so
it is given the other set of students I'm having, and I'm sure I wrote something. And I can't find it. All right, let me just add that band on this one. All right.
So, sir, so you're
Yes, Poppy.
saying work the entire thing as a whole within the parentheses first
Yes.
to get rid of the 2. They
The
all
power.
squared.
Very
so
good.
It's going to come over to be 2 bracket x raised to the power 2 and plus 1, right? And then you're going to differentiate what is inside the bracket now, which you would end up to 2x times 2x plus, and then after you plus that now, you're going to then go and say the second, correct? All right, the second mod. All right, all right, take me on this.
All right, very good.
Sir, before you
Peter,
go any
come.
further.
The second,
no, man,
Yes,
Peter,
sir.
no. You hold on,
the
man.
differentiation of the first,
You never
which
deal
is
with no
1. All right, so we have a group like terms.
Watch this now.
So
Yeah, no, don't move on yet. Yeah, you're correct, we're getting group like terms, but don't move on yet. I need to get this thing sorted out. Watch me. What is in red is my first. What is in red is my second. So you have my first and my second. So the rule says the first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. When I call the first, I'm going to write it. The first, I write it. X plus 1 times the differentiation of the second. So the second here, the second is x squared plus 1, all raised to the second power. Watch me.
Oh,
the 2 here,
I'm
going to differentiate and come right so in front of it. Then we're going to write back all of this and then raise it to the first power. Remember, it's 2 minus 1. 2 minus 1 is 1. So I have to write back all of that. All right, and then now I'm going to differentiate inside of the parentheses. The differential of positive 1 is 0. Why, sir? Because the differential of a constant is equal to 0.
0, yeah.
And when I now differentiate x squared, I'm going to get 2x, which is this 2x right here. So remember
the kicker is that it has to be multiplied again. I never think about that. So then this line now is just going to be completely working. We're going to multiply out, or we need to multiply out, and
we're not multiplying out. Yeah, we're going to multiply out. Yeah. Because the differentiation is finished right there.
All right, cool.
Differentiation is finished right here. So watch, let me just finish off this. Just watch what is happening here, guys. So every time, so we're going to just multiply out everything. So 2 times 2x is going to be equal to 4x. So I'm going to have
4x plus 2
times.
No, hold on. Stop, sir. Stop. We have a 2 outside of the bracket, right? And we have 2x squared inside of the bracket, correct?
No, man. No. We're not going inside of the brackets. We're just looking at these two numbers. We're leaving the brackets alone. Remember, we're not expanding the brackets, because you already say, you see this x squared plus 1 in another bracket there, which look like this x squared plus 1. So we now expand the bracket.
Oh,
one
all
to
right,
put the
my
bracket.
boss. All right, my boss. I get it.
So this is 2x times 2 is 4x.
This is 4x, yes. Uh-huh.
Then I'm going to write back the x plus 1. And then I'm also going to write back the x squared plus 1.
Oh, well, factorize. All right.
All right. And then no plus.
Yeah.
X squared plus
Third
1
plus
all
1.
squared.
All right.
Then now we're factorizing. We're factorizing. So we're going to say dy by dx
Yeah.
is going to be equals to what is common. Only thing that is common is going to be x squared,
X squared
plus 1.
plus 1.
What is going to be left is 4x times x plus 1
Uh-huh.
plus 1 of the x
One of the
squared
X
plus
squared
1.
plus 1. Sir.
One of the x squared plus 1, yeah, Papa.
So before you go no further, sir,
Mhm.
see that question here, you need to give me at least 3 or 4 of them, sir. For we
Mhm.
literally, all right. You see, I understand the way you go about it, sir. But you
Mhm.
so in time, you give us the rules, and then you don't explain that a rule can come within a rule. That beat me a while ago, sir. That
Yeah,
beat
but I
me a
did
while ago.
actually. Maybe you didn't remember, but I did say to you that in any of the rules you can have the product rule. So what I remember saying last week is that when you have the chain rule, you can have a chain rule, and inside of the chain rule, them give you one product, one quotient, and one next one for do.
So
right?
everybody can mix up.
Everybody can mix up into something.
Okay.
That's the point I was making, that you can't just decide, say, oh, I know the product rule, but I'm not going to do the quotient rule. You have to do everything.
All right.
All right, let's go. So now I'm going to say dy by dx.
Yeah. Are you not done this, sir? No?
No, I'm going to fix up x squared plus 1.
Yeah.
And no, let me just put something right here. So 4 times x squared is 4x squared.
So, sir, I'm going to leave it like that.
That me just ask a while ago.
It not gonna look so presentable.
Sir, we're talking about presentable, sir. We're talking about if it's going to be correct, sir.
Yeah,
presentable
but I mean,
and being correct are two different things.
Yeah, point taken, but
yeah, you gotta take 2 marks because we never go the other step. I understand.
Which is the point I'm making. So if this is a 5 marker, and you just leave it right here, you get the 4 marks, because this is the grown-up way of doing it.
What is, man?
Yeah, man. So that is going to be the answer. So
all
just,
right,
just
sir. So what
factorize.
is in yellow there? Explain
Yellow
what in
is just-
yellow there, so.
Yellow is just 4x times x is 4x squares. And 4x times 1 is 4x. So I'm distributing the 4x into the brackets. And then now I'm removing the bracket, so the x squared plus 1.
Oh, so
and then I'm
multiply
combining
that back out.
Right, and then I'm combining the like terms. So I'm gonna have 4x squared plus x squared is 5x squared. And there's only 1 4x, I write it back, and there's only 1 1, I write it back.
5x. 4x. 5. Okay, 4x and
Where's
square.
Romain and raise on Andre McIntosh, the same name?
Yeah, I don't know what I want. Sir, some of them pop in and they're about 20 minutes and then pop out back, you know, sir.
Oh,
But me they have other things that run up and down, sir.
okay. So maybe I can just pop in and then pop out too.
You can't do that, sir.
Sure, that can't work.
It can't work, sir.
Yeah, you need to let them and them know, so they have to
But,
come class
sir,
consistently. Yes, Peter.
Sir, what you can do, you know, sir, you can just give us like, you know, some questions to do, like, you know, everything I will do so far, we keep our mind, because if you're doing this now and then now you're gonna move on, and next week you do something different, you know, it's a go come out of our mind. So I was wondering if you could put some questions together.
All
and,
right,
you know,
sir,
we can
sir.
try it in the
Sir,
week. It doesn't
yeah,
have to be
just like what you
today.
said a while ago. You see all the questions, sir? Let's make 5 more
You
like
like
this, sir.
3 or 4,
Yeah, do
and
5
everything
more
will
like
do so
this, sir.
far.
Right? And
Just
then
put
you give it 5, and then you give it 5 more of the quotient mix up. Like, oh, to the you know, so we get used to understanding that if
I
we
know
get
what to
something
do.
and we see the product rule drop in at the middle of one quotient rule, we know say, all right, rah, deal with that way there, deal with this that way there, deal with that way there, deal with it. The problem is that you're gonna have a whole heap of things for mark because I'm not RAM for email and
I
WhatsApp
know
you
man,
all of them
sir, go
tools,
mark
yeah.
it when like the first 30 minutes of class, sir can just say, okay, then quick, I want to tell him the answer and he work
If him
it
not
out
gonna
quick
mark
and
it,
fast.
if him not gonna mark it.
All right. All right. Hold on. Hold up. I'm going to pull your attention to the
Mark
the
X, yeah?
last.
You buy Mark
No,
X this morning, eh?
no, man. The last document. All right.
Yeah, what a document there?
Thing there.
You the
What
email the
Send it.
document there to us, sir?
No, man. I sent
It is in
it.
group.
WhatsApp group.
Can somebody send it over again, please? Because I just
Yeah. Please send it over for Shani's sake for me, please, somebody. All right.
Now which number the calculator?
Let me ask a question. Otherwise, Kim Lando, and who is there? Candice, Kim Lando, Candice.
Yes, sir.
All right. Do you have the set of past papers? Still?
I think so.
All right, do me a favor now, please. Can you just, I would love if you could just forward those. I was looking in my stuff, but I don't see it. I would love if you could forward those in the group soonest for me, please. Anytime now, between now and a little later.
Okay.
I'd really appreciate it. If you can't find it, just ask Lando, please.
All right.
Yeah, thanks. So that
All right.
thank you, honey bunches. So that I don't have to sit and generate questions. We can just do the past papers and then I will see what exactly is happening. Now, let me tell you why I didn't send this question, because I had these questions from before. Let me tell you why I didn't send these questions. Because the aim was to give you an opportunity to go through the handout and look at the handout that I generated and do as many of the questions in those handout, in that particular handout. One of the things that I can guarantee you don't need to identify, but one of the things I can guarantee you is that some of you don't even, you see the handout, that I sent you something, but to this moment, as I'm speaking, you don't even open it yet. You don't need to identify yourself. I know that's a fact.
Oh, so we are trying, sir. We are trying, sir.
No, I'm just saying, the point I'm making is, the point I'm making is that,
we'll go through it, sir. Stick up in before. We'll go through it, but there is it's just the examples that you do yourself. I don't see any question you would like to say.
And I'm saying to you, all right, hold up, Peter. Let me tell you what I did when I was going to school for math.
Sir, that's you.
No, it works for anybody else. Let me tell you what I did. So, me couldn't afford to buy a textbook. And when me have to buy a textbook, I have to decide, okay, good boy, now go eat no lunch for a couple of days because I'm going to save some money. And my textbook was like $400. When you look into the top of my textbook, you see them writing in a pencil, $400. You understand? The textbook that must be about $40,000 an hour. $400.
All right, so
and I had to be
so give with them, sir, with them there.
No, but I use them as my reference. But the point I'm making is, me never have no textbook, so I had to depend on the questions that my teacher gave me in class, and those questions I worked. Now let me tell you what I did, and I really want you to do it. It's not the first you can hear me say so. Look at the questions that Mr. Shand would have done in class, and even when he give the answers, look on them and go through it and make sure you understand it. Then you go open one book or get one piece of paper and you write off the question. You're going to shut the screen of what my answer looks like. And you are going to sit and try and do that question on your own, from your memory, from how it is that you're supposed to know how to do the question. And then when you get stuck, you can go back and look at my solutions and see if you can pull off from there. Once you pull off from there, you continue doing the question. When you finish the question, you're going to skip a page with a new page, a blank sheet, and then you're going to write the question again. I am not going to stop attempting that question until you can do the question right through from start to finish, right? So it doesn't make sense to give you 100 questions, and out of the 100 questions, really and truly, time only affords you to do 5. It is going to put me under pressure to get those questions, and it's really not helping you. The purpose for which I would have given you the questions would have been defeated.
Sir.
Hear what I'm saying. No, I'm coming to you, Papa. Hear what I'm saying. When I give you these questions, because some of these questions that I give in the handout here are actually past paper questions. You know, when you go into the past paper, you see them, you know. So I will go into the past, when I teach in the course, I'll go into the past paper, I'll write the question, I will type the question, and I'll put it there, and I'll do the solutions to the past paper, and I'll go through it with the class. What you need to do is get the handout, look through the something, and then try producing it on your own. Trust me, if you all can do this, you'll be surprised to see the leaps and bounds that you're making with this. Before you go, Everton, Peter Gay wanted to say something. Go ahead, Peter Gay.
All right, I understand what you're saying, but I think the disadvantage, which is just my point of view, people, the disadvantage is that we're going to focus on just doing that one question. We're going to stick that one question in our mind. So if we even get something different, so we're going to start getting mixed up on it. Well, me, I must say.
All right.
So know
that I'm going to give you the past paper questions, you're going to have all the questions to do. Because it don't make sense, I again generate new questions. It's best if we do past papers because we know the level at which CCCJ writing those questions. Not that the level that I write the questions is not where they want it to. But when I would have given about maybe 5 or 6 years of papers, and I'm going to encourage you to go and generate some of these past paper questions, look through them, and sir, finish Newton Ramson, find a question, try the question, sir. I try the question, you know, and I hear some reach. The point I'm making, Peter Gay Honey Bunches, is that I want you to, not just you, but I want the whole class to take the responsibility. When sir presents some stuff to you, I want you to take it. I don't want you to become an appendage. I want you to have that level of independence. When I would have presented the stuff, and you notice what I've done is when I give you the questions in class and I type the answers and, you know, fix up the document, every time I'm sending you the updated document so that at least you can have the stuff, see what is happening. But I want you know, and Kimmy is going to say she can find those past papers for me, send those past papers. Yours is going to be the responsibility now to start working on these past paper questions. Yours is going to be the responsibility. All right? Everton, go ahead.
I'm saying what would be great is that if other than Edicosoft, you had like a test bank for like your way of teaching. Because based on how you teach, when I go on to Edico makes me so stressed out and mixed up because the way how you teach this, sir, Edico does not teach it in that manner. And it makes me very mixed up. So that is why if you notice, whenever I am doing your courses, I wait until about halfway of the course before I start doing any Edico. Because that is dangerous. By that time, what you have taught is solidified. And then I can then try jump out of the box with what you have taught and correlate between the two of them. The stage that I am now, if I jump back the last semester, sir, I do Edico till I do question till more full. I'm still mess around with Edico and Edico mash up my meds. So I'm gonna leave Edico till the last.
It's true.
Leave Edico till the last, sir, for do.
All right, guess what?
I'm still problem I have with Edico too. Anytime I go on it, sir, even if I know the maths, when I go on it, it's something different and it just gets
depressing.
Yeah, it is.
It's depressing. So like seriously, sometimes when we start something, so like we start it and then one time I do it, sometimes it take me 3-4 days to finish one exercise. And I'm like, oh my God, it's like I have to be mentally prepared for Edico. And when I go on it and you see this, it's like, even though they're showing the example, sir, but you know, sometimes they might miss that thing and you want further explanation and then no, that is not there because like literally sometimes I was doing like the critical point questions and stuff, and I have to be constantly looking at the example over and over and say, how would I get this again? While I'm going to say, sir, you can explain to me and tell me where you get that again because for some reason we can't get it and you would. But on Edicosoft, it's like, it's really depressing. So I'm going to 3 and we'll stop like, and I'm like, okay, then I'm going to wait another day. It's hard.
All right. The final thing that I'll say before I move on is that this is not the first time I'm teaching calculus 2. This, however, is the first time I'm hearing some of these comments about Edicode this, Edicode that. Other students have done it and have done very well at it. I'm going to ask you all. I'm going to ask you all.
Try little by little before.
No, hold on. No. I'm going to ask you all
Hold on, Everton.
to have somewhat of a renewed mindset. Let me tell you what I want you to do. And this is very serious. Thank you, Lord. I'm disobedient. The Lord told me to do something today, and I'm disobedient. And it comes back to the fore now. And I'm going to be obedient. What the Lord said to me is to put a few of you in the waiting room and speak to each of you one by one to let you know where your weaknesses are. And I said, no, God, that's going to take too much time.
Sir, if you do that, you're going to say Everton, your weakness is everything.
No, but I'm going to say to you, what I'm going to do, instead of doing it individually, I'm going to do it wholesalely now. Okay, a good example. And I want you to work with me. 2016, Elaine Thompson won 100 meter, 200 meter gold at the Rio Olympics, all right? 2017, she went to World Championship and she couldn't produce. She could not produce. And people spoke things about her. And quite frankly, I believe she believed those stuff. And she just could not recover. 2019, she went back to the she never medal at all, Then she went back to the 2019 World Championships, and good girl couldn't do it. And this morning I said to my wife, Elaine Thompson is going to get the gold medal. And she says, no, it's going to be Shelley. And I say, you know what? Let me tell you. Elaine has a lot to prove to all of these naysayers. Elaine's heat went first. I mean, Elaine ran and did her 10.7 little, 10.734. She was like, wow. And she looked relaxed. I said, there is more to come. There is more to come there. And she is going to be running 10.6 in order to win the gold medal. When Shericka Jackson ran and did her time, we said, wow, 10.78, not bad. And when Shelley ran, she said, see it there? I said, yeah, but you know that Shelley is an excellent athlete. No, I was at the market. I had to leave to go. So I was at the market and I'm there. I'm very upset because I really wanted to be home. Now, when me hear the whole market uproar, I say, yup, somebody won the gold. And I called home and said, who won the gold? Elaine Thompson. I said, really? I said, what was her time? 10.61. Yes, sir. All the way watch the race. So we had to be that for service seat on the race already. What's the point?
No, I'm not seated, sir. You just ruined it for me. Okay,
never mind. You know what's the point I'm making? A few of you are in your final couple of weeks at Excelsior.
You can't talk about me.
Me no want hear no excuse from nobody. Me I tell you straight, and what I'm saying to you, I'm saying it in love. Me I tell you straight up, I'm saying it in love, But me no want hear nobody come back from my class, come talk about, oh, sir, it is difficult and it is. Me no want to hear it. I don't want to hear it. What I want you guys to do is to put pen to paper and sit over it and do it. That's what success is all about. Perseverance. You're going to shed 1 or 2 year water too, I have done that. Guys, I don't want to hear it. You're going to work as if this is the last thing that your life depends on. I don't want to hear it. I come to class and I teach and I give you supplementary work and I give you the stuff on Educasoft to complete with your assessments, and you are going to do it. No, I know it is difficult. You're not doing business calculus. You're doing calculus too. I know it's difficult. It is meant to be difficult. That's the nature of calculus too. So guess what? If you have a challenge with your question, yeah, no problem. I will entertain that. But me now come back in a class and come entertain. Oh, sir, and I spent, why hear it. Save it until after the exam. So so when they spend bully for time on Edico, you're gonna say, yeah, but you pass it. Right about now. Elaine Thompson is supposed to be saying, I told you all that I could do it. Her best time going into the Olympics was 10.71, and her personal best was 10.70. It was at that time people say, oh, Rockstone, she is not too far off from her personal best time. She ran and came third at the national trials. Sherika Jackson, who stepped down from 400 meters to 100 meter, run past her like, hello, I'm my time now. And people started saying things. Elaine had to leave Jamaica and go to Hungary to go hunger for the 10.71. And it's that time people say, oh, she's almost at her best because she's just 1/100 of a seconds out of her best. And when Shelly go run 10.63, yes, man, Shelly, I care, I'm goal, yeah. Oh, Shelly and Shakari Richards are going to run. Elaine believed in herself. My wife said to me, they cannot put Elaine beside Shelly because when Shelly passed Elaine is going to crumble. She comes like Asafa Powell. I said, stop it. No, you're being rude. This was in at 5 o'clock this morning,
I think that is true.
I said, no, you're...
That's my hypothesis on it.
No. You cannot compare Elaine with Asafa. Elaine goes to these major championships and produce and get gold. Asafa Powell does not have an individual gold medal nor a silver medal. The only individual medal that Asafa has is a world championship bronze. He has gold medals from the relays. But guess what? Asafa is still one of the best 100-meter athletes that has ever lived. But he just does not have it to show. But he still goes out there and believes in it. What's the point, Mr. Shandy, saying, if you start believing in yourself here? When you speak negative things into your being, negative things will happen. You need to start thinking and speaking positive. That's all I'm going to say to you, Me can't come to class and believe in Uno. And Uno will come and say, but sir, Lord, me no want to hear it true. Me can press mute. And when you don't talk, on the call me back and say, sir, come back to the class. Me no want to hear it. No, mark you. I don't want anybody to think, you see, no, we are talking, sir, not even want to hear what concerns. That's not the point I'm making. The point I'm making is convert those negative talks into things that are positive. What God said to me when I went to make my tea is to put you all into the waiting room and speak to each of you individually. And I said, sure, yeah, no, but see it come out eventually. Students of mine, some of you still have another year at the college. Some of you are into your final semester. Some of you have one more semester. All of you that are doing the calculus 2 with me this semester, this summer semester here, should pass the course. What is it going to take for you to pass the course? Is a renewed mindset. And that's what I'm going to leave it as. I want you to have a renewed mindset starting now. Kimmy is going to send the past papers, so we have all the questions we want. Most of those past paper questions, if not all of those questions that Kimmy would send to you in the group now, I have those questions in this very handout that I would sit down and work the solution. So now that you don't have the past papers, we're not going to work it. We're going to come to class and we're going to look on it. If I send a handout, we don't want to feel like no figurine. We want to dust off when Christmas time come. Renewed mindset, renewed attitude, renewed spirit, everything about you are going to be new. Amen. Let us continue.
So we have Peter Gay, please add my phone number. I lost one of the phone numbers, one of the group. I know it's still up on WhatsApp, but eventually it them I gotta take it. I don't want to lose the info what I get. So just add. I gotta put my the other number in the chat and you add that one for me.
Yeah, because I was calling it, but sir, before we go any further, I just want to say one thing. No matter how we complain and say, sorry, it's hard, but sir, we know what have to do it, you know, we just start. We know what have to do it because nobody know I feel this again.
Me know.
But you know, I just said, hard, I can't, but sir, we have to bother, you know, sir. We have to bother everybody in here, so we have to bother.
Me not ask you that, Peter. You may tell you say half about me I tell you say half about
Exactly.
because me not
because we know
to not feel it.
We know that Elika staff are gonna help bring up our grade. So nobody no want to feel this. So all the complain, you know, like getting up and saying, I don't feel like one guy to them can't bother. But remember, say you have bills to pay, you have responsibilities that get up and go work. So no matter how we in a complain, I say, sir, we can't bother and it's hard. So we have to do it.
Yeah, but
me start from early now because me know say me no want to wait until the last minute.
The point to Peter Gay is, you know, sometimes I remember when chikungunya came out. Me never know say me did have it until me recognize say one of my finger them, you know, they feel like it want turn handicap for me. I say, oh, I didn't feel that one. It was also a finger. My right hand, that is my right hand to that I have it, you know. And then my mother had it, but she had it bad. And then on top of that, now she will catch dengue. And the woman just lay down. And I said to her one day, I say, you know, if you keep getting up every morning and say, oh, you're sick, that is going to be the death of you. Get up out of the bed. I know you feel pain, but get up and walk it off because that's what it wants to cripple you. And she said, what are you saying to me? I said, I'm don't saying it to you. And two me say my own girl out her bed in her night, you know. But goods come out her bed, man, and I walk up and down. And goods was okay. I'm saying to you, the mind is very powerful. Look at Simone Biles. A lot of people have said Simone sell out the US gymnastics team, but nobody knows what the mind does. If the mind is not where it's supposed to be, the mind can't do. So that's why the Bible talk about you have to start by the renewal of your mind. So Peter, I hear what you're saying, honey bunches. All I'm saying is that I want a renewed spirit. All right, let's go. Every time I heard you asking somebody to remind you of the quotient rule. And let me just remind you at this point in time now. It is the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. Let me say that slowly. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. One of the things I'm going to say to you is, when we get the denominator squares, we never normally go and interfere with it. Don't square it out. Make it stay as it is.
Sorry, the last part. Minus the
numerator.
The numerator
times the differentiation of the denominator all over the denominator squares. Yeah. Look back at the handout. The rule is in the handout. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. Very good. Matter of fact, I was about to work this question. I just wrote it. I'm giving you 2 minutes to start it. I'm not giving it all as 5. I want to get a head start 2 minutes. Then I'm going to command the 2 minutes of it. Then I'm going to give you another head start. We're going to work this question together because we're doing this thing. This thing not going to beat us. We're going to beat it. Start. I'm muting.
What is this? X plus 1 over 2.
How we stay? Any better?
Ish. I kind of get something, sir, but
Very nice, very nice, very nice. That is the idea. That is the spirit. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. So watch this. dy by dx the denominator times the differentiation of the numerator. Differentiation of the numerator is going to be 1 minus the numerator minus x plus 2 times the differentiation of the denominator. Once the
Sir,
power...
may they put X, sir?
No.
No? 1.
No.
All right, sorry.
1. Differential of x is 1. Once it is that you're differentiating something in parentheses and the power is greater than 1, you have to use a power rule. You have to use a power rule. Just like the denominator. So the denominator, so let's go again. The denominator times the differentiation of the numerator. The differentiation of the numerator is going to be 1 minus the numerator, which is x plus 2, times the differentiation of the denominator, which is going to be times 2 into x plus 1 raised to the first power times the differentiation of the inside, which is 1. And all of this is over the denominator squares.
Sir, me get the whole, sir, me get all of that, sir, except so I differentiate, me go put X instead of 1.
Very good. Okay, I hear you, and I hear you, Peter Gay. What I'm happy about is at least you're seeing your errors. What about the others? I'm happy that you're seeing where it is that you went wrong, and that is the spirit. What about the rest of you?
I see where I went wrong.
All right, sir.
I have
Understand.
everything except for the last, but you have 2x plus 1.
2x plus 1?
Yeah, I have everything up to I have open parentheses x plus 1 close parentheses to the second power times 1 minus open parentheses x plus 2 close parentheses times 2. So I don't have the x plus 1. That last bit there, but I have everything else.
All right. So, but you see why I get that, Orlando, right?
Yes, sir. I forgot to use the
power rule.
One.
All right, good. No, so this is what is happening. So that's why I do the questions, with you, so that you can see that. That's why I gave it a jump start, because I don't want to just go through and just do the question. I give it a jump start so that you can see what is happening. Now, here's where you're going to get on a jump start. So I've done the first line. So now make the correction for what it is that you would have had. Take a jump starter for me again now. Take the next step. I give you 1 minute to take the next step. Write the next line for me, please. Can you screenshot this for me, please?
Sure.
Yeah, I'm coming to you. Screenshot this for me, please, because the tablet is going to die. And when it dies, I'm going to lose the information on the screen. Can you screenshot it for me, please? And let me see if I can go back to the computer.
Why are you not charging the thing?
I thought, because I went to the market, I never know that the computer would have given me a problem this morning. Do me a favor, please. Just screenshot what you have on the screen now, and then let me go back to the computer. I need to do a switch over, so hold on. Give me a minute. Chance, you asking me a question, hon? Or Peter Gay?
It was me. So
okay, go ahead,
when the denominator is already squared, you hold no matter trouble it.
No, lie. Me never say so. It is always over. No, pumpkin. It's
no. Don't trouble the denominator. Leave the denominator alone. You're not working the denominator.
Yeah, but you have to square it. So even if it's square already, you have to square it again.
Yeah.
Oh.
Yeah, man. Hold on. That's important to know. So let me say it again. Guys, even if you see the denominator squared already, square it again. All right?
Because you're going to cancel it out too.
Eventually. Let me switch over. One word. Go and switch over.
Somebody post the thing in the group quick. Dot 2.
finish the other line for me?
Sir,
Yeah.
sir, I had
Mhm.
an epiphany a while ago.
Oh, cool.
Watch
Let me hear
this
it.
now. Watch
Mhm.
this now. All right. So me a madman. So let me tell you my madness now, sir. So
Mhm.
at the start of it, I have where you had your open bracket x plus 1 squared, right? That one is I did minus, correct?
All right, you broke off a little bit, so I never hear what it is that you said earlier.
All right. So what I have here, in the first line there where you have x plus 1 squared times 1. Put that back down, right? Then I
Very
have
good.
negative. So then when I hit the negative here, now I say, okay, I'm going to multiply x times everything. That is what that is x times 2x plus 1 in the bracket there. So I multiply that back out. So I end up with 2x plus I do something wrong. Yeah, clear your throat.
Yeah. Look at
because all right. So what I
look
did
at
was
this.
leave the squared because that is going to divide out in the all square that is at the bottom. It's going to cancel out that. So I didn't trouble that.
Right. So that's why whatever is in the parentheses, don't trouble them just yet. That's one of the things that I want you to do. And I said it already. Don't
No.
trouble
The
that.
first parentheses I did not trouble.
I know, but the second one is what is trouble.
Oh yeah, I did.
And I don't want to trouble. So look at that. You see that 2 right there where the spotlight is?
Yeah.
And this 1 where the spotlight is?
Yeah.
It's what I want you to trouble. So watch me now. You're gonna have minus 2 times x plus 2 times x plus 1 all over x plus 1 raised to the 4th power. Recall a to the m raised to the nth power equals to a to the m n.
Sorry, I'm gonna mess up that, sir.
Right. So it has to be
So
a to the n.
So I cannot trouble me just expand and me just multiply everything now by the x plus 2.
No, you're gonna factor out.
Sir.
Why?
Sir, it's like I know the answer and always I write this. Sir, I'm gonna work it out the same answer that you have, and then gonna do something else.
I think I know what I need to do, but don't worry about it.
Sir, so once it said the x, so you leave the first bracket alone. Sir, so what?
Hold on, I'm gone.
What is, man? Hold on. So that work out there. So if x plus 1 all squared, you leave that alone. That will go by itself. Then you're going to say 2x.
Hello?
What?
Hello? Hello?
Yes, sir. Where are you?
Okay, okay, no, it's just that the tablet died. Go ahead. Let me hear you.
Sir, so 2. Sir, where? Oh, you rearrange it.
Very good.
You rearrange. So that means sir, what on the screen?
I remember I said that the tablet dead. Yeah, so let me just share the other screen.
You have to go write that out back in, sir.
Better yet, I have it typed.
Sir, writing out better, sir. Or rather, when you write it out, sir, I'm gonna follow it better. Where were you?
I was right here. I was right. Let me spotlight it. I was right here.
All right. So 2. All right, sir. All right. What? All right. Watch this now, sir. So how? Oh, so you rearrange, you move that over, and you just put back everything in a bracket come across. So how you? So why? Oh, so everything I got times 2 now. So it no matter.
No matter. So what the error that you did was to multiply the 2 by the x plus 2 or the x plus 1.
Yes, sir. That's what I did.
Don't read. Because if you notice in the first one, you have the x plus 1. So you can factor out the x plus 1. And when you look in the denominator, you see x plus 1.
Yeah. So I'm
just leave
saying,
them.
so leave them. So then I can factor out a x to 2x plus 1. No, x plus 1. And then we can factor, if we factor out, no, but if we factor out, all right. We're right where your highlighter is, sir. Cool. The x plus 1 cubed, we can factor that out. We're going to factor that out.
Remember, you factor out this lower of the 2. So that's why you're factoring out the x plus 1.
Okay, stop. All right, stop. All right. So, all right, that line there at the bottom there. So now, how would I get that now? So would I say 2 times that. So would I get 2x? So what the 2x then? Oh, you put the squared brackets for sure, sir. Okay.
Sir, quick question, sir.
Sir, yeah, sorry, I mean to cut it, sir, but we're all right. So you have go back to the other line. Just move up a little bit, yeah. All right, so the 2x. So you said is minus 2x times 2 times x plus 2, right? Which then in turn is times, it goes times that. So 2 that, okay, so 2 times x at 2x, 2 fours, 2 2's 4. Then we're gonna get 2x again, and then we're gonna get 2, right?
Hold on there.
Sir, so why the line looks so, sir? The line look like it'll lose something, sir.
This one?
Yeah, because I get, why the hell that looks so?
What happened there?
Because if you're gonna multiply a negative times a positive, you're gonna give a negative. All right, me get that. So you're gonna get negative 2x. You're gonna get negative 2x. You're gonna get negative 2. They're supposed to get negative 2x again. Then you're gonna get a negative 1, negative 2. So
negative 4.
Oh yeah, negative 4. So why the line looks so, sir?
See the line you're talking about here? See,
So how it skip down here, sir?
Because you obviously don't sit on the line, sir.
Oh.
So what sir did was just to show you that I'm canceling out right here, sir, with 1 of the x to the 4th.
Yeah, x to the 4th.
So I'm gonna have x cubed right here.
Oh,
so
on the outside.
So all I did was cancel this and then write back the Christine version, so to speak, down here.
Yeah.
So I don't have the x plus 1 again because I canceled it one of it down here, so we have x plus 1 minus 2 times x minus 2 this. So this is now when I'm going to start the multiplication because I do the cancellation first.
All right, sir.
So negative 2 times x is negative 2x, and negative 2 times 2 is a negative 4.
All right, sir. I'm not going to make this so key, sir.
All right, Kimani.
Sir, I know I know me alone I get that, sir. I know it's not me alone I get that.
Oh,
So
yeah,
I'm tell you what we get. It's just that the third line, sir, right there, it's kind of a bit confusing because
this one?
Yes, sir. Like right there, so sir, it's a bit confusing because the second line you have the x plus 1 square minus the 2x bracket x plus 2.
Yes, sir.
So what I would do, right, sir? I'm gonna tell you what I would do. I would bring down back the x plus 1 square down here and then do the calculation, which is more than get minus 2x minus 4 and then the x plus 1. And then now I would cancel it out someone and gets so far. I would get minus x bracket x plus 2. No, my bad. When I get sorry, well, I'm gonna start it out so I can explain how we get that.
Sir, I'm gonna have to step away for a second. I'm sorry, sir. Come. Where's sir now? What am I miss?
Nothing. I just said enough Peter Gay. All right, so Peter Gay. Orlando, I hear you chiming in, Orlando. Don't think that I'm ignoring you, Papa. But your question is similar to Peter Gay's. So that's why I'm doing that. So I'm saying, do you understand this, Lando? When I say that I'm factoring the x plus 1 from the numerator since it is common to both terms?
Sir, it's because the x plus 1 is squared.
Very good. It's not, it wasn't you a while ago, Orlando?
Me, sir.
Oh, okay.
No,
sorry about that.
All right, sir. Now look on something where you have here, sir. All right. In this line, the line where your lighter is right now, right?
Mm-hmm.
4 minus 4 like 3. Okay, cool. Gotcha. I wonder where to get that. All right, cool, sir.
Peter Gay.
Yes, sir, I'm here.
Talk to me.
I'm for trying to figure it out.
Sir, where you do right, sir? Sir, where you do right, sir? Where you just highlight them there a while ago? You actually what you actually do is just cancel them, sir.
Yeah.
Just boom and cancel them and put back the and just drop this back into the bracket. So that means that is null.
Mm-hmm.
Sir, I have a question.
Yes, son.
Sir, the x one squared.
This?
Yes, sir. You can one of that for the one under the bottom, the denominator. Shouldn't it left but one x plus 1?
Thanks for asking, Shanice. So if I get you right, Shanice, you're asking right about cancel this here with this down here. That's what you're asking?
Yeah, that's
yes,
what I was
sir.
thinking.
Yeah, and get the 2.
Did I get 2?
You can only do canceling one time.
You can only cancel when you have one multiplication sign. You can't cancel with an addition sign or a subtraction sign. So if you cancel this with this, what about this term over here? So you have to first factor before you cancel.
Factor. But you have it. Me have it now and now. Me I feel like me mix up.
When I get it.
But you have something a while ago what you are jamming on my head, Virgin, and now me mix up.
Hold on.
2 minus 2x minus 1.
What is man?
So remember, you're required to factorize before cancellation. You can't factorize. You can't cancel out before you factorize.
All right. Hold on there. So you
no. Give me half a second. Let me just show you something.
And they told them my same thing. So
let us go right here. So the question is to differentiate x plus 2 over x plus 1 all squared.
The denominator times the differentiation of the numerator, which is 1, times the
minus the numerator.
Minus the numerator times the differentiation of the denominator.
Press pause.
And all right. So when we reach there now, we have to use the product rule now.
Power rule.
The power rule. And then we're going to take it from the factor that we are going to multiply. Yeah, so we're going
x plus 1.
Yeah.
You reduce this by
1. Yeah.
And then times
it by the differentiation of the middle. All right.
And then that's the numerator.
What I kind of need to remember is not to mess with the bracket. Leave the bracket alone. Differentiate it as it is. True. Then you differentiate that, and then you differentiate again. All right, cool. So now we'll get that. So then
no, hold on. We're not moving
get
yet.
until you reach
We're not moving
right
yet.
here.
Peter Gates. You get that, Peter Gates?
So I'm gonna get the first and the second one in a sir. We get
All
that
right.
one that
And
the
you
person is
understand?
at and the other one.
And you understand it's over the denominator squares?
Yes, sir. So I know how you get that, and we know how you get the other one, the other equation at the bottom, at the lower end.
Let me do something.
However,
no, hold on. Let me do something because we're not have to master this. All right, see, I break it up and say denominator squares. All right, and then now when I square the denominator, look at what is going to happen. So it's going to be the denominator right here times the differentiation of the numerator. When I differentiate the numerator x plus 2, the differential of plus 2 is a constant, 0. So I'm going to have 1. So that's a 1. Minus the numerator and minus in the numerator, which is the x plus 2 right here, times the differentiation of the denominator. So I'm going to differentiate the denominator x plus 1 all squares. Watch me. It's going to be 2 carry in front of this x plus 1 to the first, 2 x plus 1 to the first, and then now I am required to differentiate what is on the inside of the parentheses. I'm now required to differentiate what is on the inside of the parentheses. All right, don't say nothing, just watch this.
Sir, I feel like I catch a corona, sir. All of a sudden, it's started, sir. Swear.
All right. Now, let us see if I can read through what is happening here. So the recall is to apply the power rule. All right. So to apply the power rule to the x plus 1 all squares, we use a power. Let me not even just say that. Should I put it general or put it in this example? We use a power, in this case 2, to multiply in front of the base, the x plus 1. Then reduce the power by 1. And then differentiate what is on the inside of the parentheses. This then gives I know what the problem is, you know. You guys don't know how to differentiate, and that's why for 2 hours I'm on to differentiation. That's not good. 2 times.
Sorry, every morning, the first half hour of class, we have to do what we have to do one of each. Differentiation.
Don't have a problem with that. All right. Look at this now. All right. So that's my little narrative to help you to understand. So to apply the power rule to the x plus 1 all squares, we're going to use a power, and in this case it is 2, to multiply in front of the base, which is the x plus 1, then to reduce the power by 1, and then differentiate what is on the inside of the parenthesis. And this gives us all of this, which is equal to 2 times x plus 1, which is what we have here. This 2 times this x plus 1. All right? So now that we understand this stage.
Yes.
Go ahead with the question.
Sir, I understand that part, sir.
Right. So now that you understand that stage, what we now need to focus on now is the factorization part. Do you see that the x plus 1 is common? That's why I highlighted it. Talk to me now.
Yes, sir.
You notice I didn't highlight the 2?
No,
I didn't, right, because,
yes, sir.
yeah, because when I'm factorizing, I have to factorize the lower one of the 2, the lower of the 2. All right? So I did not highlight the 2. So because the x plus 1 is common, now, Shams, remember, I cannot go ahead and factorize and cancel out the x plus 1 all squares from there to the x plus 1 to the 4th power in the denominator. It is illegal. I'm not allowed to do that. I have to first.
Go again.
I cannot cancel out this x plus 1 all squares.
Got you.
With this x plus 1 here, because this x plus 1 all squares is related to this. All right? So in order for me to, it is related to it. So what I have to do is to factor out. I have to factor out the x plus 1 from it first. I have to factor out the x plus 1 first. And when I factor out the x plus 1, then I am allowed to do anything I want to do with it in terms of the cancellation. So watch me now. I'm factoring out the lower of the 2. The lower of the 2 is x plus 1 to the 1st, which is this one here. Then I factor the x plus 1 to the 1st. See it yourself? Then I'm going to say what is left. Hear me out. What do I multiply by x plus 1 to give me x plus 1 all squares? Is another x plus 1. And that's why this x plus 1 is right here. This x plus 1.
Hold on, sir. Sir, hold on. All right. So we can't go straight to canceling out. We have to factorize it first, correct? So the step down here that you're saying, how do we get the 2? So where isn't oh, all right, sir. Go on. May I skip past? All right, go on, sir.
All right. Now, when I factor out the x plus 1 from here, and I remove this x plus 1 that the cursor is on, when I remove this x plus 1, what I'm going to have left is negative 2 times x plus 2. See here? Negative 2 times x plus 2. That's how we factorize. So what I have now is x plus 1, which is this, times this x plus 1 minus 2 times x plus 2. All right? I mean,
Can you go back to it again, please?
No problem. All right, I'm going to start from here. I want you guys to create a good posture. I want you to sit up. back straight. And if you're in a bed, come out of the bed, sit up, put your back straight to the chair, both feet on the ground, and I want you to inhale properly. Inhale, exhale. Inhale, exhale. Let's go. And trust me, it's an exercise that I have to do myself. All right? So we agree on this step. We agree on that step. We know what that step is.
Yes, sir.
Good. Now, we are trying to simplify our question. But in simplifying the question, I cannot just go ahead and cancel the x plus 1 all squares with the x plus 1 raised to the 4th power in the denominator. That is illegal. Why, sir? Because the x plus 1 all squares in the numerator is related to the negative 2 times x plus 2 times x plus 1. So what I first have to do is to factorize. So I'm going to look here and I'm going to see what is common. What is common I put in blue. So you will see and agree with me that the x plus 1 is common. You will see and agree with me that the x plus 1 here is common. Okay. Now that you see that the x plus 1 is common, what I'm doing here is to factor it out. And when I factor it out, I'm going to have the x plus 1 here. Let me just...
All right, sir. This go with the premise that what you do to one side, you have to do to the other side.
No, that's not true, because that premise only works when you have an equal sign, an equation.
All right. So in essence, you need, in order for you to remove anything, you have to then
complete the operation. Complete the
operation. Good.
Right.
All right. So you take out, you have x plus 1 and x plus 1 all squared. You're going to remove one x plus 1 from the squared and take the other x plus 1 and then leave the x plus 1 that is raised to the power of 1 that is left, put that on the outside of the bracket, and then the other two now will be summarized inside of the bracket to show that they would have been collapsed into each other. And then you just put back the negative 2x plus 2 inside of the bracket. And then you can cancel out. Then you can cancel. Am I have it wrong?
Correct. You're right.
Right, cool.
Sir, let me tell you something. No, say it's what I'm supposed to do it that way. But let me tell you what I see, right? For me, what I would have done is I would cancel out, I always say one of them, what I tell you, when I cancel out the x plus 1 here, and then over here,
this
and
one?
here, so would I get, yes, sir, with the 3 of them.
No multiplication sign. Cancel when we have multiplication sign.
That's what I am saying. That's what I am saying. The way out. I know, as I say at first, sir, so enough when I explain to him and say, at first, maybe what I would do, I would just cancel out, but I still get the x plus 1 minus the 2 brackets, the x plus 2 all over x plus 1, 3. That's what I would get. That's what I would do at first. And to be honest, sir, you know, say all your talk and you explain how you get down at the one down here below the cursor, sir. But still not get it.
Sir, let me, sir, give me control for 1 minute, sir. Give me control for 1 minute, sir.
Okay, go ahead.
Give me control for 1 minute, sir. Or your request control that.
Request control.
Request control. I send it.
Yes, someone else still get the same
Sorry, you see my mouse?
thing, sir, as me I say.
No, no, I'm not seeing it.
All right. Give up remote control, request control. All right.
One.
Okay. All right. So you see my mouse, right?
Yeah.
Okay.
No. Go again.
No.
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 But I just waiting for everything.
You are control. You can control Mark Sean. But I know I'm not move. Oh, I'll go on, sir. Let's say give up control. It's I have control, but it not show my mouse. Sir, don't touch your keyboard. Don't touch your mouse. All right, sir. Don't touch your mouse. Anytime you touch your mouse, you take over back. Peter Gay, look on this, right? Look at this. You see, anytime based on what sir says, anytime you do anything and you want cancel anything from the denominator, come back up, cancel it any at all. You have to have a multiplication sign.
Multiplication sign.
So why he's saying that you can't do it here, right? Is because you have a negative sign. But when you're factorizing, you look at the two of them, right? That you're going to remove. You take this out of the equation. You take one of these out of the equation because you know that it's raised to the power 2. So you take one out of the equation for this. So these two now are going to be put inside of the bracket, correct? When you put those two inside of the bracket, because you take one out of the 2, this one is left. So this is going to be outside of the bracket. So by default, a multiplication sign is right here. And that gives you the power now to then cancel. You can't cancel not unless there's a multiplication sign. You get me? So once you cancel the multiplication sign, all right.
Get it what you say, but repeat it one last time.
All right.
So
before, all right. So sir says before you can do any canceling, you have to have a multiplication sign, right? In between them. In order for you to get the multiplication sign, you have to factorize. When factorizing, you look for like terms, right? So this is this term. This has 2 times, actually this is 2 of x plus 1 is here, and a single one of x plus 1 is here. You take one of the 2 from here and you take the x plus 1 from here. So in this essence, what you're going to be left with is x plus 1, because raised to the power of 1, which is only x plus 1, correct? And this x plus 1 would be gone. So then we're going to drop both of these, take collapse both of them into each other and put them inside of the bracket. Because you have put them inside of the bracket and you have what is simplified them, that means in order for you to get this back, you'd have to multiply. And this multiplication sign now then gives you the power to cancel. All right. For cancel. Once you cancel, once you get the power to cancel there, everything else falls into place. Because once you cancel this into this, you end up with raised to the power of 3, you minus 1, 4, sorry, you minus 1, you end up with the 3 down here, right? And the only thing you're left with is this bracket. You work what is in the bracket now. Right? All right, sir. You can give up control.
You can continue now, sir. So I don't have x.
Is that clear?
Yes, sir. I get it.
All right. Okay. So let me just pause and say something. Okay. Let me just. I have to correct something, Everton. I didn't want to break your thought. I wanted to see if you understood what you were sharing, and I'm convinced. You said that it's just a correction. You said that the x plus 1 in this equation up here is not an equation, an expression.
Okay, sorry.
All right, okay. but outside of that, you're good. Let me ask Candice and Alton and Kimmy and O'Shane and Ronaldo. Ono kind of silent. I hear from Shanice. I hear from Peter Gay. I hear
Sir,
from London.
I did say that I got it.
You got it?
Yes, sir.
Oh, me never hear you. Me never hear you. I am, hold on a minute for me, please, guys. 1 minute, please.
Yeah. What is this? Who gave it to you? Okay, show mommy.
All right. Now, all right, Candice, I'm happy to hear from you. I hear from Kimar. Alton, how is it?
X plus 2 times the X plus 2. X plus 2.
All right, let's go, guys. Let me just stop share here and divide the document. All right, so let's go. So I have with me this stuff here. I would have canceled this x plus 1 into the x plus 1 to the 4th. I'm left with x plus 1 to the 3rd power. And that's why I say x plus 1 to the 3rd power in the denominator down here. That's why I say x plus 1 to the 3rd power in the denominator. All right? Now, you notice that everything here in the numerator remains the same right here. Can you see that? Everything here remains here because all we did here was just a factor out. Sir, why did you factor out? So we could reduce the denominator. Right? So that's why we factored out, so we could reduce the denominator. All right, watch me now. Now that I have done that, sir, I see another x plus 1 here, so we couldn't cancel it right here. So the same argument goes no, because this x plus 1 is married to this other side of the expression. X plus 1 is married to the other side of the expression.
So I have to separate them with a multiple cyclation sign if it was possible.
If it is possible, very good. Right? If it is possible. Right? So you can't do that. So let's go. So in that case, what I'm going to do is to just evaluate or to simplify is a better word, not evaluate, but to simplify the numerator. And how do I simplify the numerator? I'm going to just put the like terms together. So let's just go and remove our brackets. This x plus 1 is raised to the 1st power, so I can simply write it back as the x plus 1. All right, which is right here. This negative 2 times the x is going to be negative 2x.
Yes, so you're saying that when it's raised to 1, you can just remove the bracket. That's what you're saying.
Absolutely.
Yeah, because 1 on 1, mom. 1
Every
on 1.
Time.
One time, anything raised to the power.
Once I see the bracket, I get confused at times, saying that I would have to multiply something.
Very good. But very good, Shanice. And I am right where you are. But say it this way. Once you see the bracket and the power is raised to number 1, numero uno, you can just go ahead and remove the brackets, just like that. But once the power is greater than 1, you can't do that. You got to do something else.
Right? Or you expand.
Or factorize, yes. Expand or factorize, yes. Yeah. All right, so very good, Shani. So you learned something new today again. All right, so let's go. So I'm now going to be saying negative 2 times x is negative 2x. And this negative 2 times the negative 2 is this negative 4. And I'm going to just simplify again up here, put all the x's together and all the constants together. Putting
Yeah.
all the x's together, I'm going to say that I have a 1x minus a 2x is going to be a negative x.
Yeah.
And I say I have a negative x here.
Yeah.
And this 1 minus 4 is a minus 3. So I have this minus 3 here. And of course, it's all over the x plus 1 all cube. Now you see that I have two sets of answers for this one, because it depends on how the student in question, how the student will go about doing the factorization. You could get the answer in a different form.
Sir,
All right,
can we
sir,
do
sir.
one more time, please?
Yeah. All right.
From where here?
That's fine, sir.
All right, so this is going to be x plus 1 raised to the first power. And I'm trying to simplify. Because it's raised to the first power, I can just go ahead and remove the parentheses. If it had been raised to a power that is greater than 1, I would have to do something else. All right? So having done that, I now see I have an x plus 2, but that x plus 2 is being multiplied by negative 2. So I have to go and do something to that. So it's going to be negative 2 times x is negative 2x. Negative 2 times x is negative 2x. And negative 2 times a positive 2 will give me a negative 4. So I have a negative 4 right here. And then I'm simplifying the numerator. And in simplifying the numerator, I'm going to have x minus 2x is going to be minus x. X minus 2x is going to be minus x. And 1 minus 4 is minus 3. So I'm going to have negative x minus 3. And of course, keep saying to you, leave my denominator alone. I'm not going to expand it. If I can cancel it, that's fine. But that's the most I will do with my denominator. Cancel and left alone. May not shuffle it. Leave it alone. Now, another student may see something else with the question. And that other student may say, sir, there's a negative x, there's a negative 1 in the numerator for both that I can factor out because they have a negative 1 and a negative that. I said, okay, fine. If you so desire, you could factor out the stuff. You notice that my denominator remains the same. And all you need is factoring out here to get a negative sign with an x plus 3. Then, sir, if you don't do this piece here and leave the answer there, say, could I get the full marks? Absolutely. But I'm saying based on how some students would have done the question, their answer would come out to be like this. But if you do your question come out like that. So it's either or. And that's the end of that question. That's the end of that question. How do you feel? I know, I diagnosed the situation already. Go ahead.
Sir, scroll up back to the top. I look on something. Sir, I work it by myself and I do something stupid a while ago. Scroll up back to the top. All right, cool. That 2x. So you leave the 2x and minus 1 times minus 1. That. So why am I, keep on I do that foolishness, All right, sir. I keep on you see where you have dy by dx? When I get to dy by dx, the first x plus 1, keep on expand it, sir. Keep on expand it, sir.
No.
But just at the third time I do the question since you're there talking, sir. I'm a keep on expand it, and this alone me I go wrong. All right, may I do it again? All right.
And that's the spirit. That's what I want to get you to do. You get the question, cover up your book, do it, and see how far you can get through the question. Trust me, guys. Guys, if you really want to become very good at this, that's what you need to do. Trust me. All right. I don't have much time. I have half an hour left. Let me use the half an hour wisely to to teach you differentiation of the natural logarithm function. LOGARITHM. Oh Lord.
Sir, a logs I got to teach you now, sir?
The differentiation of the log function.
Jesus. Oh Lord. Oh Lord. Sir, all of a sudden I feel like pain, you know, when you stand up in a line and you're gonna get beaten. I hear that pain feeling in your stomach. From your logs, you know, man.
No, man, you don't have to. You don't have to worry. It's one of the easiest functions. My question to you is, what's the differential of e to the x?
E to the x. E to the x.
Very good, very good. I thought you guys forgot, you know, because I was just about to tell you how Jesus loved you and cussing out, you know. I was just ready. So the differential of e to the x is e to the x, all right? The differential of ln x is 1 over x. Can't get any easier than that. So so you know that from what we did last class, that the differential of e to the x is e to the x, but there are times when the x in the power there comes with something different, and you have to go work with that something up top. For the natural logarithm, ln x, the differential of ln x is 1 over x, always. Hold on 1 minute, please.
All right, sir. What am I miss? Differentiation of nothing. dy by dx. You put what? This is what? What? What is? Sir? Sir?
I'm saying so come.
What go on here, sir? Your x is always going to be the denominator over 1.
Yeah.
All right. So whatever. Okay. So this look like whatever. You gotta convert this to a fraction then. You convert x to a fraction and then multiply it by 1. Right? So if we have so we have 5.
No man, it depends. If you notice for the second example where they have 2x, you know that's raised to the power of 2.
Ah.
Yeah, so based on the power, so you would it will always be 1 over x for ln, but then depending on the power, the value or the power of the numerator, sorry, the denominator may be different, and as such you would get it where, for example, as shown in example 2, you see it says times 2x. So it depends on the power as well, but you're right.
Cool.
They always go to a fraction.
Cool. I get you. All right. Here on my mad brain work. See how my mad brain work now, right? So x itself, any power that x is raised to, you got to differentiate it. Right?
Very good.
You come back. So, all right. So x.
It don't have to raise to anything either. I could give you like ln 3x.
Oh, sorry. What answer? Yeah, mix up the thing. What answer?
No man, it's the same thing as you're saying that I'm saying with you, know. But you're just saying you're just saying anything x is raised to. So you're looking at this. This is a question that you're looking at, you know, based on what you just said a while ago.
Yeah.
Right. So you're differentiating this x squared to give you 2x.
To be 2x.
Right.
And then you just put that, and then you just put that, and then you just turn the rest of it in one fraction.
Right. Very good. That's all it is. So remember now, very good, congrats. So you see, it says y is equal to ln x. The differential of ln x is 1 over x every single time. 1 over x, but I am
Times.
differentiating this x.
As 1.
And when I
if you-
differentiate the x, I
different-
get 1.
You get 1. Yeah, yeah,
Right.
yeah.
And one is known as a multiplicative identity. So 1 times 1 over x is going to be 1 over x.
Uh-huh.
Let us fast forward this now to the second example. Y is equal to ln x squared. The differential of ln x is 1 over x. So I can put 1 over x plus x squared. So this is this. So any way the function is, we're going to put 1 over the function.
Yeah.
Once I'm differentiating ln x, is 1 over the function.
And then
But
times it by the differentiation of the denominator.
Of the function. Yeah, which would be what the denominator is. All right?
Mad.
So I'm going to say differential of this is going to be 2x. So it's times 2x. And then when I cancel, this x cancels with one of this x.
Yeah.
Or how I did it this way, or I did it rather is to put, 2x over x squared. And this x cancels with one of these, this x here. So we're going to have only 2 over x. And this is my answer, 2 over x. All right? Look at this other one.
God.
Y is equals to ln x plus 1. Don't worry about it. The differential of ln x is 1 over x. So you put 1 over x plus 1. Now you need to differentiate what this x plus 1 is. What's the differential of x plus 1?
1.
1. So you times it by 1. So that is your answer. You see how easy it is? So let me stop and say something to you. The differential of e to the x is e to the x.
Yeah.
The differential of ln x is 1 over x.
X. Yeah.
Can't go wrong. Can't
Sir,
go wrong.
Right, sir. Right.
So, right what?
The same thing with us, sir.
Let me say all of them. You know, remember when
The differential of x. Of e to the x.
Oh, I have that already. You have that already.
That they way up there, sir. Recall. Come on, man.
Yeah, see, try to
recall, sir.
No matter of fact, I put it in a color for you. I'll colorize it. What I want you to do is to get familiar with this document. Let's go. So you see how easy one is. Let us look at number 4. Oh, Lord, sir. You're making it a little bit more complicated, but no worry about it. The differential of ln x is 1 over x. So I'm going to put 1 over 2x plus 1 to the third.
Yeah.
Then no, I need to differentiate.
Sir, we can't see bottom of my screen, sir.
But no, because the bottom of my screen have the answer.
Oh, okay.
So, y is equals to, right. So I know y is equals to ln x. Y is equals to ln x times 2x plus 1 to the third power.
Use a product rule and then say 3, 6.
Is it the product rule that you're using?
Is 3,
what rule
6x plus 3.
No.
So I gotta use the power rule for.
You're gonna use the power rule, right? You're using the power rule.
Sir, I just mix them up in sir. The name of them in sir, but I think my bit down, sir.
All right.
So I put so I
1 over
6x.
No, not going to be it's not going to be a 6x. It's going to be 1 over this here times the differential of this. So this 3 can come in front of here. So
yeah, the 3 come in front of this. So then you're gonna end up with but you did, sir, but they will still end up with the 6, sir.
But not 6x.
Yeah, man. 6x plus. Oh, so is the 2x don't turn into 6x plus.
No, that's what I'm saying.
Because they're gonna have the 3 and the 2, so you multiply it and get the 6 because the 2x
and then they multiply,
1,
so we cancel.
Yeah, mama say you're gonna differentiate.
So you're right. You differentiate on each side of the parentheses. That's why I get this 2. And so why I'm not very good, Peter. And so why I'm not interested in doing any cancellation, because when I do all of this,
then this cancel that left 1. 2 from 3 left 1. Mad.
Let me just put in an extra line into this stuff.
Magic. Peter again, you see that? You see that, Peter again?
We'll see that. We'll see it.
Madness.
You're right.
And then we differentiate the inside and get the point, the times 2 by differentiation of 2x plus 1.
That's what he has been doing all along, Kelly.
Yeah, man. We just try run through it like 4 times before me look on it and say me understand it. You get me? So, okay. So you put the cancellation of the 2 from 3 left 1, and just put back the 6. Well, then put back the 6. 3, 2, 6. 6, 1, 6. Mad. All right, cool. sir.
Yes, okay.
Nobody go no more example, because I want to get stiff a while again.
No man. What we need to do is we need to want something. We cannot have a class and.
All right,
and,
sir. Sir,
you
just
know,
spin up one question right on the corner, yes, and give it, sir. I make a see how we angle it.
hold on. Well, the corona, you know, these just using the phone carefully now, man. This needs to come through the phone, you know. The rate at which things are going, this corona have nowhere to go.
Sir, you think school are going to open September, sir?
Absolutely not.
No, you're crazy. That can't go on.
Let them go and talk where they want to talk.
Sir, so I need you to do something for me, sir. I need you to find out how the scholarship them go for the masters, you know, sir.
What you need to do is you can apply, but they're going to use a GPA from you can apply for academic scholarship, but try to make sure it is what is happening here.
Sir, I mean, no GPA if you look on, sir. I want C student. What you talking about, sir?
And don't worry about it. A C student will get the same job as an A student.
I know.
And the C student will outshine the A student. Look at this here. So what I've done is to put everything up top. Hopefully you can see, no pun intended. You can see what is happening right here.
Hold on. No, give me a second, sir. Hold on. That times. Come over times 3. That leave that to there, so differentiate that, you get 2. So 2 is equal to that. 3 is 6.
What?
Hold on, sir. Calm down, sir.
You know, he said 336. I can't be calm. He said 336.
Sir, me a madman. Hold on, sir. All right, so this cancel that.
Oh, Jesus.
Okay, baby. This cancel that. We left just the 2. The 3 and the 2, so give us 6 at the bottom. Yeah, man, sir. It makes sense. Long, sir, but it makes sense. What is it? You want a tea? Oh, okay, here it is, baby. Fine. Okay. I wonder if they want to give me 4 hours or 5 hours overtime today. I'm broke, you know. Sir, Monday holiday?
All of the day. From 12 to 12. All day Monday. They're celebrating it on
so Monday. I'm gonna wait today.
All right, so I think I prefer that cancellation method. So you look at what I did with the denominator. The denominator is supposed to be x cubed. So I break it up into x squared and to the first 4.
Yeah.
So when I cancel the x squared, you can see that there's 1 that is actually left.
Yeah.
And then my answer is going to be 6 over 2x plus 1.
Mad. But like, when I see this now, when I do it in my brain, it's supposed to start grinding it out at work.
But you know why it doesn't happen sometimes? Because you're not practicing enough. Take the question and practice. I know it's hard every time. I know you have work. I know you have family. I know you want a little me time. Yeah,
Sir, I don't need no me time, sir. I want money. Right now, that's my problem, sir. I want money. You understand? If I have money, I get a maid, right? Enough of the thing them come off of the pressure there, so. And then I can stop thinking about stress myself. I can then buy what I need to buy for my kid and pay for my kids then K5 online school and the online CXC classes what I want them doing in the summer. Zine.
Guess what?
And then
what I'm saying to you,
if me have money, everything line up, sir.
What I'm saying,
I just don't want to chop the line, sir.
You can have money, and you have the money, and you're still not happy.
Sir,
all I want you to do,
sir,
is
I know happiness.
just...
Money now give me happiness. You just have to take off the stress off of me, sir. So I
you.
can figure out what I need to do to make myself happy. Money now make you happy, brother.
Got you. All right. So now that I've gone through 5, I didn't generate more than 5 questions, 4 questions even. Now it's time for me to generate
A one, bad boy one.
Fifth question.
Mad.
I'm just continue. And as I said before, I wanted to continue with McLaren's, but sometimes in McLaren's they give you the logs function, right?
Yeah.
And like this is an example where you get a logs question in McLaren's, right? And see another question here with logs. So I have to do the log function before I even continue with the rest of McLaren's.
All right.
All right.
Sir. All right.
So let me just use
I
the
remember
other.
nothing about McLaren's right now, sir.
Okay, so let me use the other 15 or so minutes to go through by giving an example.
I only give that 2 page, you know. So what is logarithmic for what name, sir? Or what name?
Differential of the ln function. Logarithmic function, yeah.
Of the ln function.
All right. So I'll give you one right here, sir.
Sir, calculus I got in the master's maths.
I doubt it.
Sir, I still want something I want to go over it. You have 10 minutes after class done, sir.
Me talk to you. Look at this here. Do this for me, please. I want the rest of you to. I want all of you to attempt that question for me, please. Now.
All right. Y is equal to L x cube minus 5 over 3.
What time can you mute your mic, please?
Oh, sorry. My bad. Sir, I feel like me blunder big time, sir. Me do it 2 times on me and I be a foolishness me I do, sir. Sir?
All right, no problem.
Let me ask you something, sir.
Mm-hmm.
The denominator, the numerator can have a coefficient in it as the answer, or it's supposed to just be numbers?
No, so the numerator of a feature? No, it can have. It depends on the function, you know. Okay. It depends on the function. All right, let's go. It depends on the function.
So I can end up with 6.
dy by dx is equals to the differential of ln x is 1 over x. The differential of ln x is 1 over x. So it's going to be.
So I got 6x squared over.
How you get squared?
A 6x me get.
A 6x me get over x squared minus 5 squared.
What's 5?
5 minus 5 squared. 5. So it's going to be r squared because when me take out one, cancel out when me cancel out one of the 5x, the x squared minus 5 is out a cube. So then it gonna end up with you gonna have the squared left. Sorry, I don't know if I get it right, sir.
Don't worry about it. Teacher Shant are they here?
6.
And
so
he's actually correct. There's an x squared that is coming out there.
Yeah.
There's an x squared. There's an x squared that is coming out.
At the top?
Yeah. Let me just do the first part. So don't worry about the second and the third line. Second and third line is not correct. I just did the first line.
All
so
right.
ln.
Yeah.
That's a question.
Yeah.
You
idiot. So you do wrong there.
Jesus. But if you speak about yourself like that, how do you expect me to speak about you? Come on, don't call yourself an idiot. You just make a simple mistake. All right. So that's the question. Find dy by dx.
So 3x.
So it's going to differential of ln x is 1 over x. The differential of ln x is 1 over x. I'm going to have 1 over x cubed minus 5 all squares, which is this. Now I need to times the differential of this now. But this is a power rule. So it's going to be this 2 come in front of here, so see it right here, so. And this is x cubed minus 5, and I subtract 1 from here, so see the 1 up here, so. Then I differentiate inside here. Differential of negative 5 is 0. But the differential of x cubed is going to be 3x squared. Yeah, man. So what going to happen now is that I'm going to have 3, 2, 6. Sorry, my bad. Let me just fix up this stuff.
Why are you such an idiot?
No, you're not.
Gee.
You're learning.
Oh, sorry. I think the mic.
You're learning. The good thing about learning is that, at least for me, it's not about getting it right. It's about learning from the mistakes that you've made, and it goes for life. If you're in a relationship and it go bad, and you go into another relationship, learn from the mistakes you made in the first one. So, you know, it's relationship.
It looks like I'm going to be right, sir.
Sir, look at this, sir.
See a screen properly.
I know.
Sir, you know what I do? But right, there's something foolish. So you have x raised to the power cube. Me go write square, and I look back on what me I write, and I work go down, sir.
Yeah. Guess what? You are fine. You'll be fine.
Ah, crap.
You'll be fine.
I'm gonna try to start it over.
6x squared. 326, so that's gonna be 6x squared.
Minus 5x cube. So then we're gonna put this over 1.
And then this is gonna be
x squared minus 5 cube.
Alright, so let me just copy this.
Yeah, the differentiate this. Yeah, put the 3 there so you can use that. Yeah, so then we got enough works already. X squared, yeah, so this will be 2x by itself. No, you gotta differentiate this by itself again, so it's gonna end up with 3.
All right. I'll come in here. I am just trying to fix this answer. Taking longer than I am expecting, let me just copy this now. Copy. Paste. Lando, tell me to get again. Don't tell me. Look and see if that's what you got, Lando.
Yes, sir.
Very good. Very nice. Proud of you, Papa. Very
What
nice.
has been put to me all the other times that I've never used the power rule.
The power rule correctly. Don't.
Yes,
yeah, man. Very nice, Lando. This is very encouraging.
Yes, sir.
Oh, you got it.
Yes, sir.
Mark, sorry. Sorry.
Sir, do me a favor, sir. Right? I want you to do me a small favor. I want you to work back this same question, but I want you to work it with the X, with the ln. It when the question will be ln open bracket x squared minus 5 cube squared. Sorry. Work that, sir, and tell me. And a cube, I put the cube on and put the cube outside, sir. And tell me
so we will have the square. We will have the cube, put a square, and we have the square, put a cube.
Yeah.
Okay, no, I can do that. No problem.
I mean, I know
but before I do that, though, before I do that, copy number 6. Okay, I don't want it to be like that. I want to get a 6 like that. And then click paste. All right, before I go there, though, are there any questions regarding this? We're on the last couple of round of home stretch coming down, you know.
Sorry, all right, let's make this go on second. Sorry,
Candice, talk to teacher. Parchment MC. Huh?
No question.
What you know? Candice, eat a porridge. Do you eat porridge or drink porridge? What do you do with porridge?
Sip it.
No, you're an idiot. No, seriously. What do you drink with soup?
Drink porridge.
You drink porridge?
No, you drink soup.
You drink soup? Or you drink soup and you drink porridge?
You drink soup, but you eat the food in the soup.
Good comeback.
Okay. So what do you do with rice and peas?
So you eat rice and peas?
You eat rice and peas. Okay. What you do tea?
You drink tea.
So what's the difference between tea and soup?
No, sir.
Soup has food in it.
Okay.
You drink the soup and eat the food.
Okay.
So if the tea have tea bag in it, can I eat the tea bag?
No,
you eat the tea bag. Tea bag and a food.
Tea bag and a food. But you know, think about it. That's just something that I've often thought about. So let's go. So the differential of ln x is 1 over x. The differential of ln x is 1 over x. So it's going to be 1 over the function, right? So ln tell you that you can put 1 in the numerator, and then we come after ln, you're going to put it in the denominator. So that's how we get all of this on yourself. Then you differentiate now the function, but this differential, and I'm being very specific, and I'm being very deliberate by giving you all these functions with the power rule, because I know that you guys don't fully get the power rule. So that's why, so don't think that the question will have to come with a power rule. The question can come with something power rule. The question can come with something like x plus 1, or it can come simple as x squared. All right? But I am putting the power rule here because I want to kill several birds with one stone. I know you don't fully understand the power rule, so that's why I'm putting it here. But anyway, let's go quickly. Time is running. So it's going to be the differential of this. Now I'm using the power rule. Watch what the power rule says. Even if you do it, just watch it. This 2 will come and multiply in front of here, so see it here, so. And then I'm going to reduce this by 1, so that means I have to write back this and put it to the first power. See it here? Write it back, put it to the first power. Don't finish yet, because I have to know come inside. Right. And when I differentiate this, -5 is a constant. So I get 0. So that's going to differentiate this x cubed, and the differential of x cubed now is going to be 3x squared. See it here? 3x squared. Writing this line here, my differentiation ends. My differentiation ends right in that line there. Done. Finito. Then all I'm going to do is just fix up. So in this question, I rearrange right here and put 2 times 3x squared to give me 6x squared times the x cubed minus 5. And then now, because this is being multiplied by that, technically all of this is over 1. So I just ease it in the numerator now so we can see what is really happening. And you know, somehow I don't feel 100 about how me write that. Copy, paste.
Why, sir? It look perfect.
Yeah, but you see, somebody may look and not see that is a 2 that I cancel out and I leave 1. So I prefer to
mark out.
Yeah. So look at what I'm doing. So I know that I have x cubed minus 5 squares. So that's why I put it as x cubed minus 5 times x cubed minus 5 because all of this give me the 5 squares.
Yeah.
So I cancel one of that. So I'm going to be left with 6x squared over x cubed minus 5. And this is how I get that right here. So 6x cubed over x cubed minus 5. And that's how I get that right there.
Sir, the question I'm going to tell you to do over, sir. Me actually, yeah, do it and me so you get, sir. The one that when me tell you to change. Yeah. Let's see what kind of craziness we have. Because for the one that me get 6x over me get 6x over x squared minus 5 raised to the power squared. Sorry. I don't know. I miss a step somewhere. Sir, when the test when is this test fully now? You don't know yet, sir.
The paper's already written here before?
No. I mean the schedule for the test.
Which test are you talking about?
The final, sir.
I sent the timetable in the group.
No, is that not the final, sir?
I sent the 3rd draft in the group. I don't know when the final going to be. And the email
Miss Campbell, thing there because we have a clash.
Yeah,
so me email her.
Me email
and
her.
see whatever.
And somebody emailed me about some troubleshooting course that them have clashed with. And I also copied her to the email and exams. So they all have the information that there's a clash there. All right, so I'm on to the last bit of it. Give me half a second. Rockstone.
Please again, what we have a clash with? Communications?
The communication,
yeah. Yep.
Okay, hold on. I made an error of something. And to go back to the question, I couldn't see it on the screen there, so let me just go to the question now. So the differential of ln x, the answer is not correct here. So the differential of ln x is 1 over x is 1 over x squared minus 5 cubed times, this is going to be 3 times x cubed minus 5 to the second power, supposed to be to the second power times 2x. So this is going to be to the second power. To the second power, and it's over cube. Okay, to the second power.
Sure, send this as you done with it here.
Yeah, and this is second power, that is cube.
So I'm gonna mystical mixer. We have x3.
No. This is what Everton made a mistake in the same one to check to see if his answer was correct. So I'm just obliging him to do the stuff. All right, let me double check again. No, your question up here say no. Your question in a number 5. Him just make a mistake. He made a mistake and wrote the question this way. Same one to see if him right. So 1 over all of this times 3 times x minus 5 to the second power times the differential of the inside, which is 2x. So this is going to be 1 over 2 times 3, 6x x to the second power. Then I'm going to have 6x times x minus 5 to the second power over x that to the third. Okay, so to the third. So that is to the third. So let's going to put this to the first, and then put this to the second power, and then now those 2 powers will cancel out, and then I'm going to have x squared minus 5, x squared minus 5, and then we have a 6x in it. Right, so that should be correct now. So that's what the answer should be. And this cancels this, 6x over x squared minus 5. Yeah. So let me just go through this quickly. The differential of ln x is 1 over x. This will be 1 over x squared minus 5 to the third times the differentiation of what is the here which is a power rule. So it's going to be 3 in front, see it right here, so, times x minus 2 to the 5th to the second power, times the differential of the inside, which is going to be 2x, and then 2x times 3, 6x, times the x squared minus 5 squares, which is all of it right here, over the x squared minus 5 to the third. And this is representing to the third, but let us do that to show you that these two cancel out. So I'm left with 6x over x squared minus 5. And that's your answer. It's also the end of the class. Really and truly, we never did much today in terms of a new topic, so to speak. We only did some catching up on the differentiation, the product and quotient rules, and then we moved into the differential of the logarithmic function, and of course it brought back some, stuff with the thing. I'm going to end it here. Thanks for coming out as per usual. But guys, I want to show up by doing some more work and getting this thing out of the way. All right, guys?
Sir, before you go, sir, remember to do the thing on Erika's cell phone, please, sir.
Yeah, and absolutely, Kimani. I will definitely do it for you. And you and Orlando.
Yes, sir.
Yes, bless your hearts.
Yes, sir.
Cool.
Sir, open the one for me, get 0 right here. I'm going to
No
just
problem.
close the comedy there. Thank you.
No problem. Bless up.
Thanks, sir. Later.
Man, cool.
Sir, send this document now. Sir.
Hello?
Send this document now.
Will do.